Hello and welcome. My name is John Anthony Jones, and I'm in the final year of my dissertation at Tulane University. I want to thank you all for taking the time and let me share a little bit about the research that I've done on signal function and evolution in the female fairy wrens of Australia and New Guinea. If you've ever seen a nature documentary like Planet Earth or anything akin to that, conflict is inevitable. Many animals compete for a variety of resources, whether these are ecological or reproductive in nature. But aggression itself is a costly endeavor. Behaving aggressively runs the risk of becoming injured. It also takes time and energy in order to perform in these actions. And so if you can secure resources without having to pay the cost of aggression, this may be advantageous. And indeed, many animals achieve this via the use of signals. As a scientist who became one because I really like pretty colors, this is what I'm going to focus on in the context of both my talk and my dissertation in general. But I'd be remiss not to mention the fact that animals can use signals in order to court potential mates. All of the animals on the screen currently are male examples, and this is not a coincidence. And indeed, since Darwin's time, the vast majority of research exploring conspicuous color evolution has been from the male perspective. And this is really unfortunate because we know female signals are not uncommon. And indeed, the past couple of decades of research have highlighted the fact that they have a signaling function, and it does vary with respect to both males and then among taxa. But the vast disparity between male and female perspectives leaves unanswered questions. And for me, in my dissertation, I'm focused on how do females use signals in aggressive conflicts, if they do at all. One of the most common ways we can measure aggression is via the use of simulated territorial intrusions. These are really widespread behavioral assays, and the most common way we do this in birds is presenting a mount and a song combination to a focal individual. And if that stimulus is a sufficient enough threat, then the female might respond with really high levels of aggression, as indicated by this heat map. But this gets a little bit more complicated when you factor in the fact that some species respond together, where both males and females would respond to a simulated threat. Now, in this particular circumstance, this might seem a little bit like overkill or a simulated threat. Could an animal behave less aggressively and still achieve the same outcome? If you're responding with your paired mate, then this might be an opportunity to decrease your own aggressive behavior and limit those costs associated with aggression. And so we might predict this in this particular circumstance. But on the surface, if we look at this, we might also conclude that females are less aggressive than males. We're missing that vital context to really understand how does behavior and how does aggression vary among individuals. And so the intuitive way to get around this is to isolate one from the other. Now, this is hard in wild simulated territorial intrusion context because I have found that if you remove the mate, the other individual just keeps looking for them rather than defending their territory. And so we can get around this via the use of mirror image simulations. And this was done recently in the lovely fairy wren, where my colleague manipulated the plumage of both males and females, and those individuals would attack their mirrored reflection. And this is a really cool method to use and employ in my system because most passerine birds are unable to self-recognize. So if we use both of these simultaneously, we can ask a series of questions. First, is aggression related to female coloration? And then, is there any sort of social effect occurring with respect to that plumage coloration? That is to say, if we influence, or if we manipulate the plumage of a female, does her mate change? And if her mate changes, how does that dictate her behavior over time? And then finally, we can explore directly if females and males respond to differences in social context and decrease or increase behavior accordingly. So I study a bird known as the white-shouldered fairy wren of New Guinea. This is a bird that's endemic, and both sexes in this population of birds are mutually ornamented. And in females, I manipulated that white shoulder patch that you're seeing there on the screen, where I have a couple of treatments. The first is a control, which is just a sham white marker that does not influence color. I manipulated the plumage in a minor way, where I reduced the immaculateness or evenness of that white shoulder patch. And then I effectively removed the signal altogether by coloring it in. I did not pluck feathers, And it's also worth mentioning the fact that individuals who received any sort of treatment were back to normal in a couple of weeks' time, and I didn't see any long-term effects. I conducted a paired series of simulated territorial intrusions as well as mirror image simulation assays. So these look similar to this, where a female individual is responding to her own mirror reflection here. So she is displaying currently to her reflection, and she's about to attack it. So we can watch these video recorded assays over time, score them, and determine how aggressive individuals are based upon where are they in space, how often do they attack, and how often do they display and sing. So similar to the simulated intrusion approach, this is a paired design. So both prior to and after manipulation, individuals received plumage mirror trials. So the pre-manipulation assay here is our baseline score, and then immediately afterwards is important because this is a time period where individuals don't know their plumage has been manipulated. So the rival they're perceiving in that mirror is an individual of quote-unquote lower quality. We then can come back 1 week later in both assay designs and test how does behavior change over time, if it does at all. So for these analyses, I ran a couple of principal components analysis, where higher scores are overall more aggressive birds. So for the mirror assays, this is for females only because males were not manipulated. And higher scores are indicative of birds who are more aggressive over time by attacking more frequently and spent a greater proportion of time nearer the mirror. But I did not find an effective treatment on individual response. Rather, birds just became less aggressive over time over repeated assays, but this did not change with treatment. For the simulated territorial intrusions, I have two different principal components in this case, where that first principal component is very similar to our overall mirror assay scores. And then the second component is more indicative of birds who just respond quicker and sing more frequently, but are not necessarily as aggressive based upon physical altercations. It's important to note that I did not find an effect between males and females in the simulated intrusion context, and this is consistent with both my own dissertation research as well as my lab mate prior to me who did a similar study. And again, we find no effective treatment. Both males and females do not change with respect to treatment, but PC1 scores decrease and PC2 scores increase over time, over repeated assays. And then finally, to orient you along how we're measuring behavioral flexibility in this context, these are assays that are pre-manipulation. So it's sort of an apples to apples comparison where we have no effective manipulation on this. And males are pretty consistent over time. Males who have higher mirror PC scores have higher simulated PC2 scores, or intrusion PC2 scores. But what we see is the opposite pattern in females, where where females who are the most aggressive during their mirror assays were the same individuals who were the least aggressive during the paired context when she was responding to a threat with her mate. So taken together, we can answer a couple of these questions so far. We can answer if there's any, we can say rather that there is no effect, or at least there's no discernible relationship between aggression in either sex and female plumage coloration. But we can say that females are more aggressive when they are responding to a threat alone, rather than when they are responding as a pair. So we can unpack this just a little bit more. What is the signal function of female white-shouldered fairy wrens? Unfortunately, I still don't know, and that's what I've spent most of my dissertation on so far. It's worth me pointing out that I did a correlation analysis here too, where I looked at regular, or rather unmanipulated plumage coloration via spectrometry and also found no effect of aggression on color. This is a really important question to answer, and that's because we know that female plumage actually varies across the entire island of New Guinea multiple times and without a corresponding change in male coloration. And this brown phenotype is likely to be the ancestral one, and it is the one that looks most similar to their sister subspecies, or their sister species, the redback fairy wren of Australia, both northern and eastern. And so it's likely that female coloration is adaptive, but what that color actually does is unknown at this time. My earlier dissertation work suggests that it is something to do with competition, but there's still more work to be done in this system to explore how these traits evolved. Nonetheless, what we can say so far is that females are able to recognize differences in social context and respond accordingly. Females who were the most aggressive during these mirror assays recognize that in social, or when they are responding with their mate, they don't have to behave as aggressively because their mate just continues to behave aggressively. So this is a strategic mechanism to reduce their risk of conflict, but I've only been able to detect this because I used both assays at the same time. It was important. I highlighted earlier about the fact that males and females had equal simulated intrusion scores, and this is a conclusion that I drew both in my own dissertation work as well as a colleague of mine drew. And so using both these and having different contexts reveals a different trend that we may, or rather have, otherwise missed. So with that, I would like to thank, of course, the people of New Guinea, because it is an exceptionally difficult nation to work in, and none of this work would be possible without their help and assistance. And of course, I want to acknowledge my funding resources, and it is now time for my shameless plug that I am looking for a postdoc starting this upcoming summer when I graduate in May. So with that all said, I'm happy to answer any questions should they arise. My contact information is on the bottom of the screen. And yeah, have a great day and enjoy the rest of SICB Plus.